It looks good.
Okay, thanks for the introduction. I'm very honored to give a flash talk here. So today I will talk about the recollements and the localizing theorems. This is a joint work with Dongyang and Guodong Zhou. And also all the results I will give soon hold for non-positive proper DG algebras, but just for simplicity, in this talk, I will only consider finite dimensional algebras. So let A be a finite dimensional algebra over field K. I use the following standard notations. So some mode A and project A and DA unbounded derived category. And I just here singularity category is defined as the Wardell quotient of bounded derived category over the bounded home topic category of projective finite generated projective modules. So just a remark, if this one is just 0, it means the global dimension of A is finite. Yes. So we are interested in short exact sequence of triangulated categories. It means a sequence of triangle functors between 3 triangulated categories. Satisfy the following 3 conditions. First, we need I lower star is fully feasible. Then the composition of J and I is 0. So, sorry. Sorry. Yes, and J and I is that, and J star induce a triangle equivalence here. But I cannot write. I don't know what. So J star induce a triangle equivalence, and if this equivalence is up to direct summand, we call it a short exact sequence up to direct summand. If it's just can you see my screen? Sorry. Okay. So if it's just equivalence, we call it short exact sequence, and sometimes SES for short. So sorry, there are something wrong with my slides. I cannot move. So can you wait? Then let me try again. Yes. Okay. Family. So a recollement means given a short exact sequence, and if these 2 functors have right joint and also has left joint and also has right joint, we call it a recollement. It was first introduced by BBD. So a recollement just means such a diagram, such that the middle functor give us short exact sequence and they have left and right joints. And in 1992, Neeman gave the famous results. So he studied a recollement of compactly generated triangulated categories. And then he showed the top functor induced to a short exact sequence of some subcategory of compact objects. So from this recollement, we can get a short exact sequence of some special subcategories. I will not explain the details here because for our purpose, this example is enough. So let's consider the special case. So the recollement of unbounded derived categories of finite dimensional algebras like this. Then Neeman localizing theorem tells us the first top functors induced to a short exact sequence of KB project. This is because in this case, this one KB project is just the subcategory of DA of compact objects. They are same. And also, one I want to say, in Neeman's theorem, we need to take direct sum. This is because usually you take the Wardier quotient of TC over T prime C. This category may be not as important complete. But for algebra case, we do not, for algebra case, this KB project A over KB project C is always as important complete. So it's just short exact sequence. And we also interested in such a recollement. And our first result says, given such a recollement of unbounded derived categories, this middle functor also restrict to some restrict to bounded derived category. We get a short exact sequence. And the bottom functors restrict to KB int, then we get another short exact sequence. So together with Neeman's theorem, we know given such a recollement, there are 3 rules of functors. Just give us 3 different short exact sequence of different derived categories. And we also interested in other categories, for example, the singularity category. But notice, just given a recollement, the top functor restrict to KB project, and the second one restrict to DB. So there are no common functor restricted to these 2 categories. So it's harder to talk about the singularity category. So we need more functors. Our another results, if this recollement, the bottom functor 3, it has a right joint labeled by 4, then we can consider singularity category. In this case, the second rule restricted to a short exact sequence of singularity categories. This is reasonable. So just by Neeman's localizing theorem for this 3, for this recollement, the second one restricted to for our theorem, the second one restricted to DB. And this 3 rule also give us a recollement. Then by Neeman's localizing theorem, this functor also restricted to KB project. Then it's reasonable to talk about a singularity category. In fact, in this case, it gave us a short exact sequence. So let's consider some examples. So for this algebra, B, C, and finite dimensional algebras, and M is as is a BC bimodule is finite generated. Then we can construct a new algebra A. This A, we call it lower triangular algebra. This algebra has some nice properties. That is, it gives us, naturally, it gives us a recollement this form. So this 3, the bottom functor has a right joint. Then we it just satisfy our condition we discussed before. So we get a short exact sequence of singularity categories. And so if immediately, if this one is 0, it means if the global dimension of B is finite, then this map is a triangle equivalence. Or if this one is 0, then this is a equivalence. Or if DSGA is 0, then it tells us B and C must be 0. So immediately we have, if the global dimension of B is finite, then we get they are equivalence. We call it a single equivalence. And similarly, if this one is finite dimensional, global dimension of C is finite, then we get another single equivalence, and we get this. So this generalizes some results of Xiao Wuchen, and where for first single equivalence, some assumption on M is needed. But here we just assume M is a finite generated module. We don't need other assumptions. But if we give some assumption or some restriction on such module M, then we can see more. So for example, if we assume M has finite projective dimension as left C module, then this this functor, the top functor has a left adjoint, so I labeled as 0. In this case, so by our theorem before, the middle functor always restrict to dB, then we get a recollement of bounded derived categories. I think this recollement are known by many people. And by using another results, we know for using this 0, 1, 2, 3, using this for functor, we know 1 restricted to singularity category. If you use 1, 2, 3, 4, then we get 2 restricted to singularity category. So we get such a diagram, we call it half recollement. And if you assume more, assume M as left C module has finite projective dimension, and as right B module projective dimension is also finite, then we have more functors. In this case, the functor 4 has a right adjoint labeled as 5. Then we have 1, 2, 3, 5. So we have 6 rows of functors. And then in this case, when you consider these 4 functors, then this 3 also restrict to singularity category. So we get a recollement of singularity category. It was studied by Liu 5 or 6 years ago. And okay, so here is these 3 references I mentioned in my talk. So in fact, there are many references on the recollement of these triangular algebras. And also you can apply the theorem to other cases like idempotence or homologically epimorphisms. But today I do not have enough time to explain them. So I think I just stop here. Thank you very much.